All right, so then just a reminder about a couple of things. So firstly, remember that tomorrow we are following a Monday timetable. So there will be class and tutorial class at 11:20 or 11:40, whenever it is. And then there will be evening tutorial. So it's not a Wednesday tomorrow, it's a Monday timetable. And then just also remember that the semester test is next week Friday, and it'll be done via Proctorio. So you've been added to what they call an organization on a Blackboard, which will let you test out Proctorio. It's called Proctorio for Students. I'll send out a bulk email to everyone after class now, reminding everyone of this. And then also what we're going to do is we're going to set up a mock test on that you guys will take before the normal test. We'll make it a proper mock test so that you can get some practice in as well, and you can make it count for bonus marks. But it will use the Proctorio system so that you'll have an idea of what it's like to use it before the main test next week, Friday. So that's just a reminder for those things. Let me start sharing my screen, and let's start off with the code before I forget it. Okay, I see a question. VPL does not work. Shows password and username incorrect. Okay, well, send an email. I can't debug your thing now. There are some people who joined or were registered late by the faculty who then wouldn't have had a VPL password generated, but most times it's people who are making a mistake with typing in the username or their VPL password. So send an email. So that's a good question. Tomorrow we're having a meeting in the department about how to use Proctorio for administering tests on Blackboard. We'll still do the submission on Eve. I'd like to maybe do it on Friday. So that's what I'm aiming for. I just want to see on the basis of the meeting tomorrow what the impact of that is like. So I can't answer that 100% yet. So Friday is my goal. Maybe if not Friday, then I guess Monday or Tuesday, but Friday would be the best. So we do it either during the class on Friday or during the practice on Friday. Make it long enough so that people can do it at any time during the practical sessions. So one of those two would be ideal. I'd rather probably do it during the practical on Friday than class on Friday, so that we can keep going forward with the course material. So that's the goal. So we'll send out an email when we know for sure when the mock test is going to be. It'll also be posted on Eve. And yeah, I'd like to make it good practice. I'll set a whole extra test just so that you can have a new mock test to do it on. Yeah, it'll literally be same scope as the normal semester test one, full practice, so that you can get some extra practice in as well. So that's the goal. I'd like to try and do it during the semester test, not during the semester test, during this Friday's practical. Obviously, we'll make it longer in duration so that whenever you join during that those 3 sessions, you can do it. So on Friday itself, on the actual test, the following Friday, it'll be during class time. So then it'll only be during that window. We'll add extra time to allow for uploading and all sorts of other things. So you'll get lots of extra bonus time to sort those issues out. But the actual test time for the test itself will be in the class session. That's okay. That's actually a very good question. So this is now not related to semester test 1. How many different classes can be derived according to good program practice? I don't think there's a single rule of thumb, but it's like how many functions do you need to solve a problem? It's a bit of a balancing act, because if you've got only 1 or 2 really big functions, that's not good. And for the version of that problem for object-oriented programming is called the God object program, where you try and make one object too powerful and give it too many responsibilities. But at the same time, having 1,000 mini little objects that basically, like if you wrapped every single variable up in an object, that would also be bad. So I don't have a good answer to that. I'd say it depends on the problem domain that you're writing for. And basically, if every significant problem domain entity should have its own object. So if you're writing an HR system, employees are definitely a high-level problem domain entity. You should have an employee object. And contracts are probably a reasonable thing to have a class that represents them. And so, yeah, my rule of thumb would be based on the problem description. The high-level problem domain entities should each get their own object. That's where I'd start. What happens if you don't write what? If you don't write the mock test, you miss out on the opportunity to make sure that everything's working for your the actual test, which means if something goes wrong, it's on you really, because you gave up that opportunity. And it'll be for bonus marks, the mock test. So you won't lose marks, but you lose an opportunity to improve your situation. So that's what'll happen. If you don't write the actual first semester test, you're throwing away a large chunk of your semester mark and seriously endangering your ability to pass the course. The semester test is not optional. The mock test is, yeah. No, it's not. No, it's not optional. You should do it. It's stupid not to. All right. In a previous test for different subject, we used invigilation software. So the system. That's a good question. That's not a dumb question. The system does listen, so you need to have a system with a webcam and a microphone, and it does listen to the environment. But the system doesn't make any decisions about what's good and bad. All it does is it alerts the lecturers, and then the lecturers can listen to the recording or look at the video feed and make a decision. The system at no point will flag someone as cheating and say, cancel their marks automatically or, report them automatically. It only goes to the lecturers, no one else, and then the lecturers have to make a decision. You have to make sure that you get access. So that's an excellent question. What happens if you don't have a camera? You need to make provision to have access to something with a web camera. It's a requirement of the soft of the system. You can contact UJ does have a program for loan devices, which you can make use of in order to get one if you need to. But a computer with a web camera is a requirement. So no, it would not be 5% because that is an incredibly large amount. It would just count like an extra practical mark. So 5% of your you should. It's an extra opportunity to practice. I don't know, and that's something you can test. So I really don't know. As far as I know, it doesn't officially support virtual webcams. So that's where you use your cell phone or something to act as a webcam. I think it doesn't officially support them, but it may or may not work. So you can try and see. I can't guarantee anything. So that's what you can use the mock test as an opportunity for. Then you'll need to contact UJ for a loan device. You'll need to make arrangements to get a weapon. You've got 2 weeks, so you need to make a plan. All right, so is it a member or a construct that is used to initialize an object? It's a member function. It's the constructor, so it's a special kind of member function. So it's both of those things. It's a constructor, and a constructor is a member function. So the best answer is obviously constructor. Yeah, apparently, I don't think it's officially supported, but it may well work. The test is open book, so you can use your notes, and you can use the lecture slides that are on Eve. What you cannot do, of course, even if you've got access to notes, is copy and paste, because that's still plagiarism. The questions are applied, so you won't find the exact answers anyway to copy and paste, and you cannot collaborate. You cannot communicate with any other student during the duration of the test. That's really what we're more interested in than anything else. It's not about memorizing stuff. It's about people doing work for other people and dishonestly representing that. Yeah, it's under organizations. It's called Proctoria for Students, but we'll send an email out after class. Okay, that's already been answered. Okay, good. So it's been tested, and apparently it does work. So you can use the mock test on Friday to test that out. So not officially, but apparently it is possible. All right. So yeah, so unfortunately, if it doesn't work, then there's no support you can get because it isn't official. A webcam doesn't have to be an external camera. Some devices have them built in, like some laptops. So it doesn't have to be external, but it has to be a camera and a microphone. I don't understand what you say when an open book test is never really open book. It just, I think your expectations about what an open book test don't match reality. An open book test requires you to apply extra thought, because an open book test that you'd be able to just copy and paste stuff wouldn't be testing anything. So there's such a thing in education theory as a genuine assessment or an authentic assessment. So I think your expectations may be a bit out of line. All right, you already have past papers, so it's a good question, but you've actually had past papers since last week. So please make sure to regularly check the notices on EVE. If you look at the notices on EVE, you'll see that under the semester test 1 notice, there's a link to the past papers. Is the test multiple choice only? No, it's not multiple choice only. It's exactly the same format as the semester tests from previous years. So there's some multiple choice questions, some code completion questions, some short questions, and a UML diagram. To prevent collaboration. So the problem that we have is when students work together to solve questions or get other people to solve the questions for them, then you're not being tested. So I don't understand why you think that's memorizing things is useful. It's not. It's skills that you need to develop. So it's to prevent collaboration between students. So the test is open book. All right, yep. Yeah, that's correct. Okay, so you get it. Okay, so objects interact via, they can interact via a variety of, we go through past papers during the practical, during the tutorial. So if you've got, these are clearly questions from past papers, maybe just attend the tutorials and see the answers to that, because it all depends. Objects interact via message passing, and the message passing, yeah, that's how objects interact with each other, through message passing. They can relate to each other in special ways like composition, aggregation, or has-a relationships. Inheritance is an is-a relationship. But the actual interaction between objects is via message passing, just for what it's worth. Okay, well, let's continue. Maybe it's for the best. Maybe for the best. That's why, yeah, at least you're safe then from that kind of problem. All right, so let's continue, and this is probably my favorite, it's one of my favorite things you can do with objects in C++. Not all programming languages support this first thing called operator overloading, but C++ does, and I think it makes for some very nice to use classes. So let's take a look at it. All right. All right, so blah, blah, blah. There's two things we're going to cover in this set of slides. We're going to cover operator overloading and templates. And templates come in two varieties, ones that apply to classes and ones that apply to functions. Templating is a little bit trickier. So even though this is one set of slides, this actually represents 2 different weeks worth of work. So we'll do lots of examples and things in class, even if we finish the slides. During the tutorials, we'll go through obviously past papers, and I will post up an extra, it'll probably be more, there's probably 2 full tutorials worth of content in here, because both operator overloading and templates need their own separate tutorial. And in fact, what you can do, and what you'll see the second semester tests will have, is they'll use both of those techniques together. We sometimes make the templating stuff optional because it's very easy to make your program not compile if you do it wrong. And so just to avoid students getting themselves in trouble, we sometimes make the templating optional. So, but let's first start with operator overloading. So let's say, for example, you've got a type that represents time, which we've seen earlier, and you've got a bunch of functionality that you want to use it with. You want to call from it. You can print the time, or you can increment the time, or you can compare 2 times. Now, this is all well and good using member functions, but you can see that, well, there's a couple of assumptions built in. For one thing, it's very English oriented. Obviously, if you're writing code in a particular environment, the language you use to name, the natural language you use to name things will be part of your coding standard. It used to be overwhelmingly common for everything to be coded in English, even in non-English speaking countries, but that's changed now. You'll see, for example, a good example of that would be the Linux kernel, which is programmed by a Finn, but the code itself and all the comments are in English. But now it's less common. Now there's a lot of like Russian code that's coded in Russian with Russian comments, and the same for Chinese. So it used to be the case, kind of like aviation, but now it's a bit more regional, which is good, I guess. Does make the code a bit more difficult to port from one dev team to another if it's a global project, but that will all be handled in your standards for that particular company or that particular project. But anytime you can reduce dependence on a natural language to understand what's going on is good, particularly if there are conventions in the language that make sense already. So for incrementing something, plus plus, we already have that with integers. Wouldn't it be nice if I could increment my clock just by going plus plus, or decrement it with minus minus? Likewise, comparing two things like equal time, or should it be is same, or should it be equals, or should it be compare? What should I name my equality function? But everyone knows what equals equals means as an operator, so wouldn't it be nice if I could use equals equals to compare my times? I mean, this code is now much easier to understand and has fewer assumptions built into it than this code. So under certain circumstances, you'd much rather use operators, which are these punctuation things, rather than a fully spelt out member function. So with classes, the only operators that are built in is the assignment operator and member selection, so dot and equals. And the assignment operator is pretty much broken for classes by default if your class has dynamically allocated memory on the inside. Because by default, the assignment operator does what we call shallow copying, where they just copy the raw values of the data members. It doesn't, for example, if you've got a dynamic array, it doesn't automatically allocate a new array and copy everything across. It just will copy the raw pointer, which is very dangerous, because then those two objects will share the same state, and the first one that goes out of scope will delete the array, breaking the other object. So very, very bad. So assignment works kind of if your object is very simple, and member selection obviously works perfectly fine. That you wouldn't change. But operator overloading is sort of extending or changing how an operator works to be specific to your new programmer-defined data type. So for example, we could define what plus plus means in the context of times, or equality means in the context of times. So there are restrictions, but even within those restrictions, it does allow you to make some very useful data structures that are easy to work with. And just on that note, this is something that's considered to be what they call syntactic sugar. It doesn't actually add any functionality to the language that isn't possible without it. You won't be suddenly able to solve problems with operator overloading that you couldn't solve with regular member functions. Because as we'll see under the hood, operator overloading is just a fancy way of doing certain kinds of member functions. But anyway, most of the pre-existing operators can be overloaded. There are some that can't. There are other restrictions. For example, you can't add new operators. So you can't make up a whole new punctuation sequence and then have that be a thing. So if you couldn't, for example, implement X as an operator for cross product between vectors, that wouldn't be possible. Or you couldn't implement the middle circle symbol to be function composition between functional objects. That you can't do. But you can change the behavior of something like plus, because that's a pre-existing operator, or minus, or multiplication, or incrementing, or equality, or inequality, greater than, less than. Most operators, you can change their behavior. To specify that a particular function is going to represent an operator overload, there's a new keyword. So you should start getting nostalgic when you see new keywords being introduced, because you're actually reaching kind of close to the end of where you'll see new keywords as you learn C++. So operator, it's a new keyword that you can understand, or that you can use. To be honest, I often pretend, although it's not really true, pretend that operator is actually part of the function name, because that makes it easier to reason about. But as you'll see, you can use it as a standalone keyword as well. So the syntax is like this. It's like a normal function definition, a return type, operator symbol, that will be the name of the function, and then a parameter list just like any other function, and the keyword operator. In the style that I prefer, I tend to write operator and the symbol immediately next to each other, so it looks like one function name, because under the hood, that's actually what it is. It becomes one single function. So in this particular example, it's a value returning function. Operator is a keyword. And then to overload the operator of a class, you've actually got two choices, to be honest. One is you implement it as a member function, which we'll try and do whenever possible, but in some cases it's impossible. And then you basically define it in the header file and then implement it in a CPP file like you would normally. Here are some of the restrictions. So you can't change the precedence or associativity of an operator. So things like plus and minus bind less tightly than multiplication or division. You know, your BODMAS rules, PEMDAS, however you learned it. You can't change that and suddenly make multiplication at the same level as subtraction. It must always be at the same level as division. You can't change the associativity rules either. Remember, there's two levels in expression evaluation. There's precedence, so the operators that will occur first if the brackets don't distinguish between them. And then if you've got operators of the same level of precedence, then the associativity kicks in. And that says we read them left to right or right to left. So it used to be very common on social media to have those very long mathematical expressions and then bet you can't answer this, and then you'd read it and most people would get it wrong and you'd be like, how can you get it wrong? Almost all of those rely on associativity tricks. People forget which operators are left associative or right associative. So they might get the brackets and they might get the multiplication before division thing wrong. But if you've got a mixture of addition and subtraction, sometimes it's important to note the associativity as well. So you can get conflicting definitions or conflicting answers if you don't remember associativity rules. You can't use default parameters with operator overloading. You can't change the number of parameters, which is technically referred to as the arity of the operator. So for example, you can't suddenly make a version of plus that takes 3 inputs. There are 2 versions of plus that exist by default. There's the there's the unary plus, which takes no argument, 1 argument. Binary plus, which takes a left-hand side and a right-hand side, and that's it. Same with multiplication or multiplication, although technically for multiplication it's not multiplication. So there's 2 versions of the asterisk operator. There's the unary one, which is if you want to make something that behaves like a pointer, we will do. When, like, say, you wanted to create a smart pointer type of your own. So that's what unary asterisk is. Or there's the one that behaves like multiplication. And they both have the same symbol. So there are 2 different arities for this one particular operator, but you couldn't suddenly make one that takes 3 or 4 or 5 things. Likewise, yeah. So that's a restriction. Can't create new ones. There are only a handful of operators that you can't change overload at all, and that's member access, because that's too low level for function. The whole system is built on top of member access. If you were to change its behavior, you break everything. However, interestingly enough, the arrow operator is completely allowable to be overloaded. So you can, if you want something that behaves like member access but different, you can overload the arrow operator instead. This one here is not dot and multiplication or dot and dereferencing. It's a very rarely used operator that lets you index into a pointer, a member into a pointer. It's almost never used. It's not the same thing as the arrow operator, so don't worry about that. The scope resolution operator, which you've seen for function name, to fully qualify function names, and you've seen it in namespaces. And you, for example, if you're saying things like standard string to drill into a namespace, so you can't change that one's behavior, and you can't change the ternary operator. Not sure if you remember the ternary operator, but it's the equivalent of an if statement. So let's say I had integer a equal to 1, and if, let's say, a is equal to 1, then let's say we got b equals 0, and let's say if a is equal to 1, then we're going to have b equal to 9, else b equals 8. You could write that again instead rather as equals test for A equal to 1, value if true 9, value if false 8. So this ternary operator is very unusual. A, because it's the only operator that takes 3 inputs, and B, because, well, actually that's the main thing that makes it weird, but you're not allowed to overload it, so that's restricted. I'm sorry, I'll check for questions in a moment. And you can't change the size of operator either. Technically, size of is an operator. Most people use it like a function. I often do that as well. So let's say you had a struct with 2 things inside it, int A and bool B, and you wanted to know how big these things were in memory. You could go size of, and I typically write it like this, but actually, strictly speaking, it's an operator. No one writes it out that way. Function. That's fair, right? All right, so now let's just go back and see if there's anything else there. And then, yeah, so you can't change the behavior for built-in types. So you just can't suddenly make addition mean subtraction for integers, and you can't suddenly make not equal to and equal to or for booleans or whatever. But you can only define it in terms of your data types that you're introducing. But you can mix. You can say, let's say, a combination of your type and a pre-existing type. So you could define, let's say we've got a set, it's not a bad idea, a set S, that's a set of integers, let's say. Let's say I wanted to add something to the set. Let's say I wanted to add 1 to the set. I could definitely write an overloaded operator that took a set and an integer as inputs. So they don't both have to be. And I could then also have, let's say it's set 1 and set 2. You can have, of course, different versions for different combinations of things. So S1 and S2 to combine the 2 sets together, that's definitely legal. So those are the restrictions. Let's go take a look at questions. Okay, so that was where I got to. Yeah, definitely WhatsApp is an absolutely terrible idea if you're talking about collaboration. If you are part of a WhatsApp, this is why the only official collaboration platform that you guys should use is Discord, and do it on the public channels. If you're on a WhatsApp group and someone shares an answer, you could all be subject to disciplinary action, up to and including expulsion, even if you weren't the person who shared it. And Google, not allowed. You can't just go Google answers and things. You can use your notes. You can use notes you've written. Anything you could access from Eve is fine, but going off and Googling stuff, definitely not okay, because then that's someone else's work that you're going to try pass off as your own. So these slides haven't been uploaded yet. Thanks for reminding me. I'll upload them now after class. So thanks for the reminder. Yep, good call. Yeah, you and your notes. That's it. Okay, syntactic sugar. It means it's something in the language that's nice to use. It makes it prettier and easier to use, but it doesn't actually make the language more powerful. So operator overloading is an example of this. There's no problem. There's no system you can't build without, or that you can only build if you have operator overloading. Everything you can do without it. But sometimes it's nice. So it's a nice to have. That's a very interesting question. There's actually an entire field of programming they're called DSLs, domain-specific languages. And they're definitely a kind of syntactic sugar. And some programming languages let you define your own languages inside them. Things like Scala is a good example. You can define your own, you can basically change the rules of the language in the language. So in that, yeah, there's definitely an overlap there. So syntactic sugar is like a custom programming language, yes. In the case of operator overloading, it's pre-built in and you have some control, but not much. In other programming languages, you can basically rewrite the language as you go. So yes, that's perfectly right. So operator overloading is legal redefining of existing built-in functions. Let's say functionality, because it's operators. We will implement them as functions, but obviously the low-level ones aren't functions. They're built into the instruction set for the CPU, things like integer addition and multiplication and so on. So functionality. Is the interface the same as the header files we use now? No, but this is a good question. So the question, and I can relate this to computer science too as well. So an interface in Visual Basic or an interface in the Java programming language is effectively something like this. if I have a class, I'm going to call it interface, and the only thing inside it is pure virtual functions and constants. So I don't know, void virtual void m, virtual void act. I said pure virtual, so equals 0. And let's say you're allowed to have some constants. So I don't know, static const int magic number. Right, this is equivalent to an interface in Visual Basic or Java. And those languages will let you do multiple inheritance of these things, because you can see it's impossible to trigger the diamond problem, because the only kinds of functions that are in them are pure virtual. So you'll never get conflicting definitions because there's no definition at all. Constants are obviously not an issue either. So that's a very good question. But that's the C++ equivalent of an interface in that sense. I'm not sure which point. Oh, no, I was just saying, I think I was just showing you examples. So this here is just an example of the asterisk operator with one operand, right? So that's just saying that the same symbol can have different meanings in different contexts. So if you use the asterisk symbol like this, it's got one parameter, and if you use it like this, it's got two. So some operators can have two or one or two versions. For example, let's say minus. If you've got a number a, you can say a minus 1, that's fine. Or you could say minus a, where you negate whatever a was. So this is a unary version and a binary version of the same operator. So those are good questions. Do the built-in functions or the language itself? So they're defined in the compiler, but they might also be implemented in standard libraries, so that varies. Operator overloading redefines our own operators made in previous projects. This can be combined with built-in operators. Yes, absolutely. Yeah, in an expression, you might have a mix of the pre-built ones and your own ones. That's perfectly fine. Oh, pure. You know what? I agree fully. I hate that notation. Pure, or just, I think in Java, it's the keyword is called abstract. So if you just think, if I remember correctly, actually it has been a while since I've used Java. So, you know, something other than this virtual void equals 0, but it is what it is. So this is we're not initializing the virtual function, and I'm glad you asked, because this is good revision. So if we don't put that equals 0 there, it means that the implication is that there will be an implementation for this function, right? Even if that implementation is empty, this must exist. But if you do this, it becomes a pure virtual function, and there will be no implementation in this class for that function. But in any derived class that extends it, we would then provide an implementation for ACT derived. And it does whatever it does. So that's what it looks like, initialization. This is why I don't like the syntax, because it looks like you're initializing it. But that's what it actually means. It means no implementation is provided in this class. It's not really a safety net. It's in a way it's kind of the opposite, because actually, if you forget to implement them at some point, then you can have compilation issues. So in a way, it's kind of less safe than just having an empty implementation that does nothing. The purpose is to signal that this particular function is so abstract that it has no meaning by itself and can only be provided with meaning in a derived class. So it's actually more likely to cause an error if you do it wrong than if you just have an empty implementation in the base class. So those are good questions. Let's just carry on. I've got a bit more time. Okay, so we've actually worked with this pointer before, and we've actually, since we implemented pseudo objects ourselves from the ground up, you actually know what this is. It's an automatic parameter that gets added to the front of every parameter list for the member functions that refers to the current memory address or the memory address of the current object. So you've built it yourself from the ground up. But as you've seen in C++, it comes it comes with the objects for free. And as part of implementing some of the operators, we'll make use of this pointer, you'll see. Here's something that's interesting. And we'll use it when we have to. But I don't like them, but there are situations where they are absolutely required. I think we can end off on this because this will definitely require a worked example to drive home. So a friend function is a non-member function of a class, but it's been upgraded to have access to the class's private states. So think of it like if you've got things that you need to keep private, right? That means that they're really only there for you to touch. But if someone's a very good friend of yours, you can give them access to your privates. But it's dangerous. You shouldn't give access to your privates to just anybody, because then they could break your privates, which would cause problems. So friend functions are very powerful. It lets you upgrade a function's access to a class so that it can access the private state, but limit the amounts of friend functions you use and only do it in the very controlled circumstances because it is risky. And there is one situation where we will have to use it. And let me actually, so how do we do it? We declare it in the header file. It looks like a member function, but then when we implement it, you see it doesn't get fully qualified. It's just implemented like a normal function. I think I'll end off with an example of when we would use it. So it's a good place to end off any new content. So let's take a look. Let's say we had a class that's a number, right? And let's say it wraps around an integer. I'm not going to go into too much private. And I don't know, I'm not going to think too hard about this. Value, blah, blah, blah. But let's say we want to be able to add nums together using the plus operator. So what we can do is we can have a function. We can implement that in one of two ways. We can implement it as a member function, which is the way we will try and do it most of the time. So operator plus, and let's say we want to be able to add normal integers to our numbers and get back a number. So let's say we want that. I'll call that the right-hand side. And let's look about what that would mean. So, okay, I'll implement it, but let's not get too bogged down in the details and keep this super simple. But so let's implement it, num, operator, blah. See, this is why I like ended operator as part of the name of the function. Think of it as a function called operator plus. And then we wanted to return that. So we're going to make a new number. I don't know, object, and we're going to initialize it with our current value plus right-hand side. Then we're going to return object. So that's handling one kind of addition. So let's think about this now. So if we're in main and we wanted to use our num. So num n. Right, let's set it equal to 0. And let's say we wanted to add 1 to it. So let's say, let's make two nums. Let's go num n and 2, 0. And let's say I wanted to make n be equal to n2 plus 1. This is fully fine, right? Not a problem here. What's the compiler going to do? It's going to say n is equal to n2, and it's going to replace that plus there with a call to our special function, operator plus 1, like that, and then it's going to look, oh, okay, I'm looking for something that takes an integer. Oh, here's the function that takes an integer, perfect, gives back a num, that's compatible with that, perfect. So now n will have the number 1 inside it, which is perfectly good. But what if we wanted to do this now? Let's say n is equal to 1 plus n2. So, okay, fine. Syntactic sugar, let's fix that up. 1 dot operator plus, and then n2. And then it's like, okay, firstly, we've got a problem. We don't have a version of that defined that takes a num. We've just got the one that takes an integer, but that's not the main problem. The main problem is this nonsense. 1 is just a number. It doesn't have any member functions inside it. So this is obviously broken, wrong. So what we actually would want instead is we would want it to convert it to something like this. A regular function called operator plus that takes 1 as its left-hand side and n2 as its right-hand side. And this would be okay. The problem is that this is now no longer a member function. So we need to define a non-member function version of operator plus, which we can do by saying that we make it a friend function called operator plus. And now we have to specify both the left-hand side and right-hand side. You can see here, we don't specify the left-hand side because this is automatically taken as being the left-hand side, because this is automatically added as an extra parameter to every member function. Here, friend is not a member function. It's just we're upgrading another function's access to our private state. So we have to specify both the left-hand side and the right-hand side. So they num n and int. Oh, let's just keep it easy to understand. Num left-hand side and int right-hand side. Then we would implement this as a regular. Let's give it a return type. We'd implement this as a regular function, right? So it doesn't get fully qualified. We don't add num colon there. We just treat it like a normal function. And now we can make our num, whatever, object, and make it equal to left-hand side dot underscore value. And you see now, this is where the friend comes in. I can access value, which is private to the num class, even though this isn't part of the num class, because we made it a friend. So num value plus right-hand side. Plus right-hand side, and now this will work fine. So when we do 1 plus n2, it will convert it to that function call, which will match this. Oopsie, did I specify those the wrong way around? I wanted a integer as the left-hand side. Sorry, integer left-hand side, and a num as the right-hand side. Sorry, in and then this must obviously then be right-hand side dot value. Let's just write them. We expect it. So left-hand side plus right-hand side of value. Okay, that's better. Now this matches what we've got over here. Integer on the left, num on the right. Convert it to this. This matches. No problem, and we're done. So that's the basic idea and the basic reason why we have two options, where we can do member functions, which we'll do whenever we can. But in this situation, to get these kinds of expressions to work, we can't use a member function. It has to be a non-member function. And for that to work, we need access to the private value. So we need to make it a friend function, which is where we get to over here. All right, so that's the basic idea. I'll carry on with that going further. I'm just going to answer any questions. That's correct, perfectly correct. That's why you should, because if you type something on Discord, if some idiot firstly shares something, we can block it, and we won't punish you because we're in charge of that channel. So it's not your fault if someone does something like that. In fact, we'll disable the ability to post messages during the test, so that's fine. It is difficult to get used to. It's one of what they call computational thinking. It's one of the basic skills you need to develop for computational thinking is abstraction. So abstraction is about focusing on only the parts of this problem that are relevant and ignoring the rest. So in a class hierarchy, if you've got a function that deals with just people and you don't care what kind of person they are, you can use inheritance to create that abstraction. But abstraction can be created by a whole bunch of different things. This is just a tool to create abstraction. So encapsulation, okay, so abstraction is about removing non-relevant things from your solution and only focusing on the key stuff. You can do that through inheritance and other ways. Encapsulation is data and behavior together in a single entity. That's what it is. And I think what you're thinking of the hiding here is the information hiding. Information hiding, for example, could be using private variables to hide the implementation details from anyone who doesn't need to know. So this needs to know, this needs to know, this needs to know, but the person using the class here doesn't need to know how it's represented internally. So that's information hiding. It can help you realize abstraction. Do getters and setters already not pass the price? Okay, look, so this is a good point. Could we have written this member function without needing direct access to value? And the answer is yes. Of course, we could have written it, added an accessor, and then called the accessor. That'll be slightly slower, but it will work. So you don't always have to immediately leap to a friend function as the only way to do things. If you have accesses for that part of the state you need, you can skip the friend function portion. If you want to. So that's a good point. What happens in the case of star star? So there's no star star operator, so you can't overload it. Would we need to give any friend access during this module? I'm not talking about human friends. We're talking about different classes that are and functions that are granted access to each other's private state. It's not a friend in the real sense. It's a keyword that's used to represent the ability to skip the information hiding protections. So notice that with the protected and with inheritance, there was actually a whole separate class that was created and then became a kind of number. Here we don't create a separate class. We just create a function, sorry, operator plus, and upgrade that function's access to the private state. So there's no is a relationship being created. Oh, code. Did I give a code? I don't know if I did. I don't remember giving a code. Oh well. Yeah, fine. The code is right. Thank you. All right. Okay, I'm not sure if that's a question, so if it is, you can ask later. So a friend is a complicated way of avoiding messages members before. Yes, that's basically what it is. It's something that can be overused. So I only use it when you're forced to use it. So yes. Yeah, it does have meaning in Python. Obviously in C++, depending on where they occur, could mean a double pointer, but it's not a separate operator. It's simply the indirection operator being applied twice. So that's that. Okay, so thank you very much. I think we're done. So I'm going to stop recording and end here. I'll send out the email reminding people about the Proctorio organization that you can access to access the Proctorio for Students resources. And then after tomorrow, I will know about whether or not I can set up a mock test for you guys on Friday. All right, so thank you very much. Cool. All right, so I'm going to stop recording.